Welcome back everyone. Today we are going to start chapter 12, algebraic expressions. So it is a very interesting chapter. 12.1 Introduction. We have already come across simple algebraic expression like x plus 3y minus 5, 4x plus 5, 10y minus 5 and so on. In class 6, we have seen how these expressions are useful in formulating puzzles and problems. We have also seen examples of several expressions in the chapter on simple equations. We have seen that expressions are a central concept in algebra. This chapter is devoted to algebraic expressions. When you have studied this chapter, you will know how algebraic expressions are formed, how they can be combined, how we can find their values and how they can be used. So 12.3, how are expressions formed? We now know very well what is a variable is. We use letters x, y, l, m, etc. to denote variables. A variable can take various values. Its value is not fixed, so that's why it is called a variable. On the other hand, a constant has a fixed value. Example of a constant are 4, 10, 100, minus 17, etc. We combine variables and constants to make algebraic expressions. For this we use the operations of addition, subtraction, multiplication and division. We have already come across expressions like 4x plus 5, 10y minus 20. This expression 4x plus 5 is combined from the variable x first by multiplying x by the constant 4 and then adding the constant 5 to the product. So it is very simple. Similarly 10y minus 20 is obtained by first multiplying the value 10 and then subtracting 20 from the product. The above expressions were obtained by combining variables with constants. We can also obtain expressions by combining variables and themselves or with other variables. Look at how the following expressions are obtained. X square, 2y square, 3x square minus 5xy, 4xy plus 5, 7. The expression x square is obtained by multiplying the variable x by itself. So when we multiply x by itself, it becomes x square, just as 4 into 4 is equal to 4 square. So we write x into x is equal to x square. It is commonly read as x squared. Later, when you study the chapter exponents and powers, you will realize that x square may also be read as x raised to the power 2. So when you will study exponents and power, you will know that. In the same manner, we can write x into x as x cube. Commonly, x cube is read as x cubed. Later, you will realize that the x cube may also be read as x raised to the power 3. So x, x square, x cube and so on are all algebraic expressions obtained from x. So the second is the expression 2xy square. 2y square is obtained by y. 2y square is equal to 2 into y into y. Here by multiplying y with y we obtain y square and then we multiply y square by the constant 2. Third is in 3x square minus 5. We obtain x square and multiply it by 3 to get 3x square. From 3x square we subtract 5 to finally arrive at 3x square minus 5. So xy, we multiply the variable x with another variable y, thus we get x into y is equal to xy. Fifth is in 4xy plus 7. We first obtain xy, multiply it by 4 to get 4xy and add to 7 to get 4xy to get the expression. 12.3 Terms of an expression. So we shall now put us in a systematic form what we have learnt above about how expressions are formed. For this purpose we need to understand what terms of an expression and their factors are. Consider the expression 4x plus 5. In forming this expression, we first formed 4x separately as a product of 4 and x, then added 5 to it. Similarly, consider the expression 3x square plus 7y. Here we first formed 3x square separately as a product of 3x and x. We then formed 7y separately as a product of 7 and y. Having formed 3x square and 7y separately, we added them to get this expression. You will find the expression we deal with can always be seen this way. They have parts which are formed separately and then added. Such parts of an expression which are formed separately first and then added are known as terms. So it is called terms. And look at the expression 4x square minus 3xy. We say that it has two terms, 4x square and minus 3xy. This term 4x square is a product of 4 into x into x, and the term minus 3xy is a product of minus 3 and x and y. Terms are added to form expressions, just as the terms 4x and 5 are added to form the expression 4x plus y, 4x plus 5. The term 4x square and minus 3xy are added to give the expression 4x square minus 3xy. This is because 4x square plus minus 3xy is equal to 4x, because plus and minus become minus, therefore minus 3xy. Note the minus sign is included in the term. In the expression 4x square minus 3xy, we took the term as minus 3xy and not as 3xy. This is why we do not need any to say that terms are added or subtracted to form an expression. Just added is enough. Factors of a term. We saw above that the expression 4x square minus 3xy consists of two terms, x square and minus 3xy. The term 4x square is a product of 4x and x, and we can say that 4x and x are the factors of the term 4x square. A term is a product of its factor. So we know that term is a product of its factor. The terms minus 3xy is a product of the factor 3, minus 3x and y. We can represent the terms and factors of the terms of an expression conveniently and elegantly by the tree diagram. So you can see the tree diagram in this figure. The tree for the expression 4x square minus 3xy is shown in the adjacent figure. So you can see here is an expression. Note, in the tree diagram we have used dotted lines for factors and continuous lines for terms. This is to avoid mixing them. So you can see that they have used a continuous line for terms. You can see these are continuous line for terms, and for factors they have used dotted lines. So you can see here the expression is here. Here is the term and here are the factors. And similarly for second example, 5xy plus 10. First term is this and second term is this, and by dotted line they have defined the factors. Let us draw a tree diagram for the expression 5xy plus 10. We have seen that the factors are such that they cannot be further factorized. Thus we do not write 5xy as 5 into xy, because xy can be further factorized. Similarly, if the x cube were a term, it would be written as x into x into x, as not x square into x. As also remember that 1 is not taken as a separate factor. So coefficients, we have learned how to write a term as a product of factors. One of these factors may be numerical and the other is algebraic. That is, they contain variables. The numerical factor is said to be the numerical coefficient or simply the coefficient of the term. It is also said to be the coefficient of the rest of the term, which is obviously the product of algebraic factors of the term. Thus in 5xy, 5 is the coefficient of the term. It is also coefficient of xy. In the term 10xy, 10 is the coefficient of xyz. In the term minus 7x square y square, minus 7 is the coefficient of x square and y square. So very easy. When the coefficient of a term is plus 1, it is usually omitted. For example, 1x is written as x, 1x square y square is written as x square y square, and so on. Also the coefficient minus 1 is indicated only by the minus sign. Thus minus 1x is written as minus x, minus 1x square y square is written as minus x square y square, and so on. Sometimes the word coefficient is used in a more general way. Thus we can say that in the term 5xy, 5 is the coefficient of xy, x is the coefficient of 5y, and y is the coefficient of 5x. In 10x y square, 10 is the coefficient of xy, x is the coefficient of 10y square, and y square is coefficient of 10x. Thus in this more general way, a coefficient may be either a numerical factor or an algebraic factor or a product of two or more factors. It is said to be the coefficient of the product of the remaining factors. Example number 1 we are doing here. Identify in the following expressions terms which are not constants. Give their numerical coefficient. So you can see here 4x xy plus 4, 13 minus y square, and so on. So you can see there is serial number and there are expressions. So you can see here is the expression terms which is not a constant. So xy is not a constant, it's variable. So it is written here xy. Numerical coefficient is written 1 because before xy there is 1. That's why. And here also you can see 13 minus y square. So minus y square is the term, and the coefficient is minus 1. Before variable there is minus 1. So you can see minus 1. Here also you can see 5y square 13 minus y square y plus 5y. So you can see there are two terms, minus y and 5y square, and coefficient is 5 and minus 1. So you can see here minus 1 and 5. 4 p square cube 3 pq square plus 5. So you can see here and this is a term and this is a term. So this is written here, and 4 is a coefficient and minus 3 is a coefficient. So it is written there. So example number 2, what are the coefficient of x in the following expression, and second one also, what are the coefficient of y in the following expression. So first one you have to find the coefficient of x, and in the second one you have to find the coefficient of y. So here the coefficient of x is 4. So you can see here coefficient of x is 4 and terms are 4 for x, because we have to use only x, so that's why 4x is the factor. So here also you can see this is a minus x is the term, and the coefficient is minus 1. Here you can see y square x and y. So you can see y square x is the term, and factor is that coefficient is y square, because with x there is coefficient y square. 2z minus 5xy. So minus 5xy is the term, and the coefficient is minus 5z. So you can see here with x there is minus 5z. So here we have to find the y. For the coefficient of y we are finding here. So here the term is minus 3y and coefficient is minus 3, and here also you can see yz is the term and z is the coefficient. Here also you can see yz square is the term and z square is the coefficient, and m by is the term and m is the coefficient. Very easy. 12.4 like and unlike terms. When terms have the same algebraic factors, they are like terms. When terms have different algebraic factors, they are unlike terms. For example, in the expression 2xy minus 3x plus 5xy minus 4, look at the term 2xy and 5xy. The factors of 2xy are 2x and y. The factors of 5xy is 5x and y. Thus, their algebraic, that is those which contain variables factors are the same, and hence they are like terms. On the other hand, 2xy and 3x have different algebraic factors, they are unlike terms. Similarly, the terms 2xy and 4 are unlike terms. Also the term minus 3x and 4 are unlike terms. So now 12.5 monomials, binomials and trinomials and polynomials. So you can see here an expression with only one term is called monomial. For example, 7xy minus 5m 3z square 4x etc. are monomial. Now an expression with contain two unlike terms is called binomial. So you can see, for example, x plus y, m minus 5 mn plus 4m and a square minus b square are binomials. The expression 10 pq is not a binomial, it is a monomial. The expression a plus b plus 5 is not a binomial, it contains three terms. Now an expression which contains three terms is called a trinomial. For example, the expression x plus y plus 7 b plus a plus b 3x square minus 5x plus 2 m plus n plus 10 are trinomial. The expression ab plus a plus b plus 5 is however not a trinomial, it contains four terms. You can see here there are four terms, not three. The expression x plus y plus 5x is not a trinomial, as the term x and 5x are like terms. In general, an expression with one or more terms is called a polynomial. Thus, monomial, binomial and a trinomial are all polynomial. So you can see in example 3, state which with reason which of the following pair of terms are a like term and which are not unlike, which are unlike terms. So you can see here there are pairs 5x 7x 12y first, and the second one is 15x minus 21. You can see here the factors are also again 7x and 12y. You can see here they are different, they are unlike terms. The variables in the terms are different. This is the remark. So you can see here also you can see they are same and they are like terms. So everything is given here. So you can see here same. Remember AB is equal to BA. Everything is given. So there are different things. So they are also different. For following simple steps will help you to decide whether the given terms are like or unlike. Ignore the numerical coefficient, concentrate on the algebraic part of the term. So you should always concentrate on the algebraic part of the terms. Check the variable in the terms, they must be the same. Next, check the power of each variable in the term. They must be the same. Note that the deciding note that in deciding like terms, two things do not matter. One, the numerical coefficient of the term, and second, the order in which the variables are multiplied in the terms. So here is an exercise, you can solve it, and if you have any doubt, you can ask it in the comment section. 12.6 Addition and subtraction of algebraic expressions. Consider the following problems. 1. Sarita has some marbles. Amina has 10 more. Appu says that he has 3 more marbles than the number of marbles Sarita and Amina together have. How do you get the number of marbles that Appu has? Since it is not given how many marbles Sarita has, we shall take it to be x. Amina has then 10 more, that is x plus 10. So Appu says that he has 3 times more marbles than what Sarita and Amina has. So we take the sum of the numbers of Sarita and Amina's marble, and to this sum add 3. That is we take the sum of x plus 10 and 3. So here second is Ramu's father's present age is 3 times Ramu's age. Ramu's grandfather's age is 13 years more than the sum of Ramu's age and Ramu's father's age. How do you find the Ramu's grandfather's age? Since Ramu's age is not given, so we will take it as y years. Then his father's age is 3y years. To find Ramu's grandfather's age, we have to take the sum of Ramu's age y and his father's age 3y and the sum add 13. This is we have to take the sum of y, 3y and 13. Third is in a garden, roses and marigolds are planted in square plots. The length of the square plot in which marigolds are planted is 3 meters greater than the length of the square plot in which roses are planted. How much bigger in area is the marigold plot than the rose plot? Let us take the L meter to be the length of the side of the rose plot. The length of the side of the marigold plot will be L plus 3 meters. Their respective areas will be L square and L plus 3 whole square. The difference between L square plus 3 ka whole square and L square will decide how much bigger in the area marigold plot is. In all the 3 situations, we have to carry out addition or subtraction of algebraic expressions. There are a number of real life problems in which we need to use expressions and do arithmetic operations on them. In this section, we shall see how algebraic expressions are added and subtracted. So adding and subtracting like terms, the simplest expression are monomials. They consist of only one term. To begin with, we shall learn how to add and subtract like terms. So let us add 3x and 3y, 4y, 3x and 4x. We know x is a number, and so also are 3x and 4x now. 3x plus 4x is equal to 3 into x plus 4 into x. So we know that 3 plus 4, we are taking x common using distributive law. 7 into x is equal to 7x. So since variable are numbers, we can use distributed law for them. So 3x plus 4x is equal to 7x. Let us try add 8xy, 4xy and 2xy. So we are adding this. We are separating this and taking common xy. 8 plus 4 plus 2 will give 14xy. So 8xy plus 4xy plus 2xy is equal to 14xy. Let us subtract 4n from 7n. So 7n minus 4n, we take 7 into n minus 4 into n. We will take n common. So it will become 7 minus 4 into n is equal to 3n. Therefore, it is equal to 3n. So 7n minus 4n is equal to 3n. In the same way, subtract 5ab plus 10ab. So 5ab minus 11ab minus 5ab. So we will take ab common. 11 minus 5 is 6ab. Thus, the sum of two or more like terms is a like term with a numerical coefficient equal to the sum of the numerical coefficients of all of the like terms. So you can see here. Similarly, the difference between two like terms is a like term with a numerical coefficient equal to the difference between the numerical coefficients of the like term. So it is given here. Note, unlike terms cannot be added or subtracted the way like terms are added or subtracted. We have already seen examples of this. When 5 is added to x, we write the result as x plus 5. Observe that in x plus 5, both the terms 5 and x are retained. Similarly, if we add the unlike term 3xy and 7, the sum is 3xy plus 7. If we subtract 7 from 3xy, the result is 3xy minus 7. Adding and subtracting general algebraic expressions. Let us take some example. Add 3x plus 11 and 7x minus 5. The sum is 3x plus 11 plus 7x minus 5. Now we know that the terms 3x and 7x are like terms and also are 11 and minus 5. Thus further we will do 3x plus 7x is equal to 10x and 11 plus minus 5 is equal to 6. You know that. So we can therefore simplify the sum as 3x plus 11 plus 7x minus 5. So it will the like terms 3x and 7x will come together and it will become 10x, and 11 minus 5 will become 6. So we have rearranged the terms. Hence 3x plus 11 plus 7x minus 5 is 10x plus 6. So add 3x plus 11 plus 8z and 7x minus 5. So the sum is 3x plus 11 plus 8z plus 7x minus 5. So we are rearranging the term. So x and x will come together. So we will have 3x plus 7x plus 11 minus 5 plus 8z. So we have rearranged that. Note we have put like term together. The sum and the single unlike term is 8z will remain as it is. Therefore the sum is 10x plus 6 plus 8z. So another example is subtract a minus b from ab from 3a minus b plus 4. So difference will become 3a minus b plus 4 minus a minus b. So it will become 3a minus b plus 4 minus a plus b. Observe how we took a minus b in brackets and took care of signs in opening the bracket. Rearranging the term to put like terms together, we have difference is equal to 3a minus a will become 2a and b minus b plus 4. So 1 minus 1 will become 0, this will become 0, whole thing will become 0 and this will become 2 and the whole will remain as it is. So you see there 2a plus 4. Very easy. We shall now solve some more example on addition and subtraction of expression for practice. So here is example number 4. Connect like terms and simplify the expression. So you can see 12m square minus 9m plus 5m minus 4m square minus 7m plus 10. So there are m square, there are two terms, m has 3 terms and 10 will remain as it is. So we will take all this together and we will first take m square together. So 12 and 4 are m square, 5, 9 and 7 are in the terms of m and plus 10. So we will take the m square as common. So it will become 12 minus 4. Here we will take m common. So 5 minus 9 minus 7 plus 10. So it will become 8m square plus minus 4 minus 7m plus 10. So 8m, this will become 11. So it will become minus 11m plus 10. So minus will come outside. 8m square minus 11m plus 10. Very easy. Example, subtract 24 ab minus 10b minus 18a from 30 ab plus 12b plus 14a. So we have seen that we will take all this together, all this term. So first of all we will write this term and then we will subtract this from this. So we have taken this first, 3ab plus 12b plus 14a minus, and this whole thing will be inside the bracket, 24ab minus 10b minus 18b. So when the minus will go inside, the sign will be changing. So that sign it will become negative, 24ab will become negative and these two will become positive, positive b and positive 18a. Now we will rearrange the terms. AB and AB will come together. So 30AB minus 24AB and 12B plus 10B plus 14A plus 18A. So when we will subtract, it will become 6AB and this will become 22AB and 18 plus 14 is 32A. So alternatively we write the expressions one below the other with the unlike term appearing exactly like below. So you can do like this also. When you do like this, the signs will be changing, and because it is subtraction, so it will subtract and this will become positive and this will also become positive. So it will become 32a, this will become 22b and this will become 6ab. So very easy. So sixth is, from the sum of 2y square plus 3yz minus y square minus yz minus z square and yz plus 2z square, subtract the sum of these two. So we have to subtract from the sum of this, we have to subtract the sum of this thing. So first we will add this two and then that one. First we will add 2y square plus 3yz minus y square yz minus z square and yz plus 2z square. So we'll write like this. y square will come together, yz will come together, and the z square will come together. So we are adding all this. So when we add, so this is in negative, so it will remain negative, so it will become z square, because it is 2z square is bigger, so the positive will be given here. And in this one, these two will get cancelled, and this one will come as it is, 3yz, and here 1 will be minus, so it will become y square. So we then add the second term, which is given this thing. So 3y square minus z square we will write below with the z, so it will be easy for you to add it. And then in the negative minus, you will get y square plus yz plus z square, and when you add this, you will get z and z will cancel, and this will come as it is, and it will come 2y square. So now we have to subtract 2 from 1. So we'll write this, and below this we'll write this. So we have to subtract, so sign will be changed. The first thing is given here, you can see here, the first is given here, the second is given here, you are subtracting it. So this will become minus because 2 is higher, so you will get minus here, and here yz will subtract, so it will become 2yz, and z square will come as it is. So it is an exercise, you can solve it, and if you have any doubt, you can ask it in the comment section below. Now 12.7, finding the value of an expression. We know that the value of an algebraic expression depends on the value of the variables forming the expression. There are a number of situations in which we need to find the value of an expression, such as when we wish to check whether a particular value of variable satisfies a given equation or not. So we'll find values of expression also when we use formulas from geometry and from everyday mathematics. For example, the area of a square is L square, where L is the length of a side of the square. We know that if L is equal to 5, then 25 will be the area of the square. If the side is 10 centimeter, the area will become 100 centimeter square, and so on. We shall see more such example in the next section. So for example number 7, there are 4 questions here. Find the value of expression when x is equal to 2. So we'll put the value of x in these expressions. So x plus 4, we'll put in x plus 4, we get the value of x plus 4, that is x plus 4 is equal to 2 plus x is equal to x plus we'll put the value x as 2, so we'll get 6 as answer. Second is 4x minus 3. So 4x minus 3, you will put 2 in the place of x, so it will become 4 into 2 minus 3, it will become 8 minus 3 is equal to 5. Similarly here also we'll put x value in the place of x, so we'll get 2 square, so 2 square is 4, so 4 into 5 20 minus 19 minus 20 is equal to minus 1. Very easy. Now 100 minus 10 x cube, so 2 cube is 8, so 8 into 10 is 100, 8 into 10 is 80, 100 minus 80 is 20. So you can see here they have solved it. You can do it like this also. 100 minus 10x cube is equal to 100 minus 10 into 2 cube. So we know that 2 cube is 8. So 100 minus 10 into 8. So we can do that. 100 minus 80 is equal to 20. Find the value of the following expression when n is equal to minus 2. 5n minus 2, 5n square plus 5n minus 2, and this third one. So putting n is equal to minus 2 here. So when we put minus 2 here, you know that it will become minus sign will come outside. It will become minus 10. Minus 10 minus 2 is minus 12. Now in here you can see 5n square, when at minus 2 is inside square, it will become positive. You know that. So you can see here n square will become 420, and we are combining the first one and second one. So n square plus 5n minus 2 is equal to 20 minus 12 is equal to 8. So the first one was solved here. So you can see that it is easy, nothing to worry about. And third one is n cube plus 5n square plus 5n minus 2. So in this also you can put in n cube, you know that when you put n cube it will become 8, so it is an odd, so negative sign will remain as it is, so it will become minus 8. And when we put the value of n here, so n is minus 2, so here the n cube will become minus 8, and here we will put n square, so minus 2 will become positive 4, because it is square, it will become even will become positive. So 10 into 2 5 into 4, 2 square is 4, so it will become 20, and then here also it will become minus 2, that is minus 10 minus 2. So here is minus 8 plus 8 is equal to 0. So when we solve this, it will become 0. We shall now consider expressions of two variables, for example x plus y, xy. To work out the numerical value of an expression two variables, we need to give the values of both variables. For example, the value of x plus y for x is equal to 2 and y is equal to 5 is equal to 3 plus 5 is equal to 8. So you can see here, example now, find the value of the following expression when a is equal to 3 and b is equal to 2. So you have to put simply the value of a and b. So here a plus b. So a is 3 and b is 5. So b is 2. So it will become 5. A plus b is equal to 5. 3 plus 2 is equal to 5. So now the second one is 3a minus 4b. So we are putting the value here, 7 into 3 and minus 4 into 2. It will become 21 minus 8 is equal to 13. A square plus 2ab plus b square. So we will put the value here. 3 square in the place of a, it is 3. So it will become 3 square plus 2, 3 into 2 plus 2 square is equal to 9 plus 2 into 6 plus 4 is equal to 9 plus 12 plus 4 is equal to 25. Very easy. A cube minus b cube. So a cube minus b cube is a cube 3, 3 cube minus 2 cube. So it will become 3 into 3 into 3 minus 2 into 2 into 2. It is 9 into 3 minus 4 into 2 is 24 minus 27 minus 8, that is 19. So here is an exercise. You can solve it by the above methods. If you have any doubt, you can ask it in the comment section below. So 12.8, using algebraic expressions, formulas and rules. We have seen earlier also that formulas and rules in mathematics can be written in concise and general form using algebraic expression. We see below several examples. So perimeter formula is there. The perimeter of an equilateral triangle is 3 into length of its sides. If you denote the length of its side, the equilateral triangle by L, then the perimeter of the equilateral triangle is 3L. Similarly, the perimeter of a square is 4L, where L is the length of the square, side of the square, and perimeter of a regular pentagon is 5L, where L is the length of the side of the pentagon, and so on. So area's formula is here given here. If we denote the length of the square by L, then the area of the square become L square. If we denote the length of the rectangle by L and its breadth by B, then the area will become L into B, LB. Similarly, if B stands for the base and S stands for the height of a triangle, then the area of triangle will become 1 by 2 B into H, that is BH upon 2. Once a formula, that is the algebraic expression for a given quantity, is known, the value of the quantity can be computed as required. For example, for a square, length is 3 cm, the perimeter is obtained by putting the value of L is equal to 3 in the expression of the perimeter of square, that is 4L. The perimeter of the given square is 4 into 3, that is 12 cm. Similarly, the area of square is obtained by putting the value of L is equal to 3 in the expression for the area of a square, that is L square. So 3 square is equal to 9 centimeter square. So rule for the number pattern. Study the following statement. 1. If a natural number is denoted by n, its successor is n plus 1. We can check this for any natural number. For example, n is equal to 10, its successor is n plus 1 is equal to 11, which is known. So when its successor is n plus 1, so n is equal to 10, we'll add 10 plus 1 will become 11, which is known. Second is, if a natural number is denoted by n, 2n is an even number and 2n plus 1 is an odd number. Let us check it for any number. Say 15, 2n is equal to 2 into n, that is 2 into 15 is equal to 30. Indeed, an even number, and 2n plus 1, so it will become 2 into 15 plus 1 is equal to 31. So it is indeed an odd number. So you can do this. Take small line segments of equal length such as a matchstick, toothpick or pieces of straw, cut into smaller pieces of equal length, join them in pattern as shown in the given figure. So you can observe figure 12.1. It consists of repetition of the shape square made of 4 line segments. As you can see, for one shape you need 4 segments, for 2 shape you need 7, and for 3 you need 10, and so on. If n is the number of shape, then the number of segments required to form n shape is given by 3n plus 1. You can verify it by n is equal to 1, 2, 3, 4, and so on. For example, if you take the number of shape formed is 3, then the number of line segment required is 3 into 3 plus 1, that is 9 plus 1 is equal to 10, as seen from the figure. You can see in the figure. Now you can consider the pattern as in figure 12.2. Here the shape is like a U is repeated. The number of segment required to form 1, 2, 3, 4 shapes are 3. 4, 7, 9 respectively. If n stands for the shape formed, the number of segments required is given by expression 2n plus 1. You can check the number of expression in corrected by taking any value of n, say 4, then you can add, put a number of n is equal to 4, so you can get 2 into 4 plus 1 will give 9, so which is indeed the number of line segments required to make 4 U's. So you can see here. So here is the try this section. You can try this. Go ahead and discover more such patterns. So you can do this also. Make the following pattern of dot. If you take a graph paper or a dot paper, it will be easier for you to make the patterns. Observe how the dots are arranged. You can see here how the dots are arranged in a square shape. If the number of dots in a row or a column in a particular figure is taken to be the variable n, then the number of dots in the figure is given by the expression n into n, that is n square. For example, take n is equal to 4. The number of dots for the figure with 4 dots in a row or a column is 4 into 4, that is 16, as is indeed seen from the figure. You may check this for other values of n. The ancient Greek mathematician called the number 1, 4, 9, 16, 25 square numbers. Some more n number patterns you can see here. Let us now look at another pattern of numbers, this time without any drawing to help us. So we can see here there is a pattern 3, 6, 9, 12, 3n. So you can see the number in which they are multiplied is 3, arranged in an increasing order. So you can see it is multiple of 3 beginning with 3. The term which occurs at the nth position is given by the expression 3n. You can easily find the term which occurs in the 10th position simply, which is 3 into 10, that is 30. 100th position is 3 into 100, that is 300, and so on. Pattern in geometry. What is the number of diagonals we can draw from vertex of a quadrilateral? So you can see here, check it, it is 1. You can see here from one vertex of a pentagon, how much you can check it, it is 2. From a one vertex of hexagon, you can draw 3. So it is very easy. The number of diagonals we can draw from one vertex of a polygon is of n side is n minus 3. Check it for a heptagon 7 side and octagon 8 side by drawing. What is the number of the triangle 3 sides? Observe that the diagonal drawn from any one vertex divide the polygon in as many non-overlapping triangles as the number of diagonals that can be drawn from the vertex plus 1. So you can see here is an exercise. So you can solve it. If you have in doubt, you can ask it in the comment section below. So here the chapter is finished. We will start the next chapter in the next class. Thank you.